An absolute value inequality is an inequality that contains an absolute value expression. We're trying to find all of the x values that will create a true statement if we plug them back into the original inequality. If you think about absolute value as being distance from 0, this expression, or this inequality, the absolute value of x is less than 2. The x values that we put in there, the absolute value, so when you turn it to positive, those values need to be less than 2 units away from 0. So if you think about on the number line, if you're at 0, the places where you can be less than 2 units away from 0 are from 0 out to 2 and stopping at 2. So absolute value less than creates that inequality that's shaded in the middle. We call that an and inequality. So absolute value less than creates and inequalities. If the absolute value, if the distance needs to be larger than 2 units away from 0, that means it can't be 0, it can't be 1, it can't be 2, it has to be bigger than that. So it has to go from 2 out and from -2 out. That creates the inequality that's split, pointing in opposite directions. That is known as an or inequality. So absolute value less than creates an and inequality, the 3-part, oops, I should use pink, the 3-part negative something less than x less than positive something. And a greater than absolute value inequality creates an or inequality. To solve absolute value inequalities, if you have absolute value of stuff is less than c, you do -c less than stuff less than positive c. And I want you to think less and than. Less than creates and inequalities. Less than creates and inequalities. Greater. I want you to think great or. If we have absolute value of stuff is greater than c, we rewrite it as stuff is greater than c, that one doesn't change, or stuff is less than -c. That one changes both. This one creates an or inequality. I want you to think great or. So in our examples, we're going to do 2 and inequalities and then 2 or inequalities so you can practice both of those. And then we'll talk about something involving negatives, and then we'll have time to work on our assignment. Number 8 and number 9 are both less than inequalities. Less and than inequalities. So right above this, I would like you to write and, so you remember that less and than, less than and, however you can remember that. Less than is always an and inequality. And there's not a ton of space here, so I'm going to write this over to the side. To take this absolute value inequality and rewrite it as an and inequality, we do -11 is less than 2x plus 7 is less than 11. So you're taking this 11, putting negative on the left side, the positive on the right side, with the stuff from the absolute value in the middle. Do you remember how to solve that kind of inequality from a couple days ago? Okay, so take a moment, solve that inequality. Should end up with -9 is less than x is less than 2. Good so far? And these are the ones that are really easy to graph, and I think you'll appreciate how detailed my graphs are. There's the -9, there's the 2. Open circles or closed circles? Open circles, and inequalities we shade in between. Okay, let's try number 9. Anyone want to be brave and try to write the inequality? Yeah?
Negative 21 is less than or equal to 4x minus 9 is less than or equal to 21.
Perfect. So because this one has a less than or equal to, you do the same thing as number 8. You just put a less than or equal to symbol in. So you're taking the 21, take the opposite of that, less than or equal to the stuff in the absolute value bar, less than or equal to positive 21. Take a moment, solve that one. Negative 3 is less than or equal to x is less than or equal to 7.5. Or if you wanted to leave it as 34ths, you could, or you could also change it to 15 halves, but decimals are fine. And then on your number line, we'd use closed circles at those two numbers and shade in between. Number 10 is a great or. So if you want to write or next to number 10, greater means we have to write it as an or inequality. The first inequality, you simply write without the absolute value bars, but you don't change anything else. So 3x minus 2 is greater than or equal to 8. Don't change anything. Write or. For the other inequality, we don't change anything on the left, but we change the symbol and we change the number on the right. So instead of greater than, we write less than or equal to. And instead of positive 8, we write negative 8. So when you write the second inequality, you have to flip the symbol and take the opposite of the number that comes after. Okay, now on your own, solve both of those inequalities, and then we'll talk about graphing them, even though there aren't graphs shown. Did you get x is greater than or equal to 3.33 or 10/3, and x is less than or equal to negative 3? I should say or in between those, not and, but did you get those two answers? Negative 2, because 6 divided by 3 is 2. You know. This is why I check. Maybe I did that on purpose to see if you were paying attention. I didn't, but, you know, I could have. It could have been strategic. All right. When you're graphing these, you do want to be a little bit careful because x is less than or equal to negative 2. That number is going to appear on the left of your number line. Some teachers are very, very picky and want you to rewrite it with x is less than or equal to 2 first, and then x is greater than or equal to 3.33 on the right so that it transposes onto the graph easily. I really don't care. As long as you graph it correctly, we're good. So we've got negative 2 and 3.33 on the graph. Less than or equal to, greater than or equal to, so those are filled in circles. Or inequalities always point in opposite directions. But you can also look at your inequalities. X is less than or equal to negative 2. We have to shade to the left of negative 2. X is greater than or equal to 3.33. We have to shade to the right of 3.33. The first thing we need to do in number 11 is write the two inequalities. It's a great or than, so we need to write an or inequality. The first one, don't change anything. Negative 3x plus 10 is greater than 5. The other inequality, keep the left side the same. Flip the symbol to less than. Take the opposite of 5. Okay, on your own, solve and graph both of these. I'm going to keep the video running for those of you watching the video, with a lot of noise in the hall, apparently. Five thirds is 2.67, correct? Okay, a reminder, when you divide by negatives, that is going to flip your symbols. 1.67. See, I'm just making all sorts of mistakes today. Mental math, you know. Okay. To graph this, because this one flipped around, it's actually now written correctly the way other teachers would want you to write it, so that's helpful. Open circles. X is less than 1.67. That would shade to the left. X is greater than 5. That would shade to the right. All right, let's talk about a scenario where we have absolute value of something is less than a negative number. What if it says absolute value is less than a negative number? We know that negative numbers are kind of weird with absolute value because absolute value can't equal a negative, but this time we're talking about inequalities. So let's pick some x values and plug them in there. If I put 5 in there, what is the absolute value of 5? Is 5 less than negative 2? No, it's bigger than negative 2. Can you think of any number that we could put in there where the absolute value of that would end up being smaller than negative 2? Absolute value of 1 is 1. 1 is not less than negative 2. Absolute value of negative 3 is positive 3, which is not less than negative. You'd have to put a negative outside of the absolute value, but there isn't a negative out there, so it's a no solutions. And if you think of it in terms of distance, absolute value is distance from 0. It is impossible for the distance to be smaller than a negative number because a negative distance doesn't exist, so you can't be smaller than something that doesn't exist. Now let's talk about the same sort of thing with what if the absolute value needs to be greater than a negative number? Okay. Let's plug numbers in. If I put 5 inside those absolute value bars, what's the absolute value of 5? Is 5 bigger than negative 2? Yes. The absolute value of anything is positive, and a positive number is always going to be bigger than a negative number. So this would give you all real numbers or many solutions. Basically, anything in the world that you put into that x would create a true statement. On the pink one over on the left, any number you put in is going to create a false statement. Nothing works. The green one on the right, anything you put in is going to work, so all real numbers work.